All right, so this type of problem is called the dual problem. It's the minimization problem with constraints of all of the form greater than or equal to. So we're minimizing c equal to 16x sub 1 plus 8x sub 2 plus 4x sub 3. So we do a little bit of scrap work here. You write an A matrix down with the constraint equations first and then the optimization equation last, but you don't move any of the variables in the optimization equation over. In other words, I'm making this A matrix. The three constraints are 3, 2, 2, 16. This could be a big matrix augmented by the solution. Next one is 4, 3, 1, 14. 5, 3, 1, 12. And again, this can be dashed or solid, doesn't really matter. Next one is the constraint equation, but write it down as 16, 8, 4, and then the 1c on the right. So 16x sub 1 plus 8x sub 2 plus 4x sub 3 equals to one of these c's. So this is just scrap work, but it's getting our minimization into a maximization, a maximizing optimization function. So taking my minimizing and turn it into a maximizing. So what was row 1, you write down as column 1. So the 3, 2, 2, 16, row 1 now becomes column 1. The 4, 3, 1, 14, row 2 becomes column 2. The 5, 3, 1, 12, row 3 becomes column 3. And row 4, 16, 8, 4, 1 becomes column 4. And this is our transposed matrix. We call this A superscript T. All right, so transpose of A. So now we rewrite those down, but now we write it down as a maximizing function. So we write down 16, and we change the variables from x sub 1s to y sub 1s. 16y sub 1 plus 14y sub 2 plus 12y sub 3, and instead of c, we call this p. So now we're trying to maximize, and again, we got this from this final row, trying to maximize p equals 16y sub 1 plus 14y sub 2 plus 12y sub 3, subject to these new constraints, but these new constraints are greater or are less than equal to now. So the 3, 4, 5, 16 becomes 3y sub 1 plus 4y sub 2 plus 5y sub 3 less than or equal to 16. And then 2y sub 1 plus 3y sub 2 plus 3y sub 3 less than or equal to 8. And finally 2y sub 1 plus y sub 2 plus y sub 3 less than or equal to 4. And now we just solve this like we would normally do a standard simplex equation or standard simplex problem. So for the p's, I would move everything to the left-hand side. Negative 16y sub 1 minus 14y sub 2 minus 12y sub 3 plus the p is equal to 0. And just like I told you in class, I'm going to use x sub 1, y sub 1, and x sub 1, x sub 2, and x sub 3 as my slack variables. So I take this 3y sub 1 plus 4y sub 2 plus 5y sub 3 plus the slack variable x sub 1 is now equal to 16. And then 2y sub 1 plus 3y sub 2 plus 3y sub 3 plus the slack variable x sub 2 is equal to 8. And 2y sub 1 plus y sub 2 plus y sub 3 plus the slack variable x sub 3 is equal to 4. So hit pause. I'm going to take a second and write this down as a matrix, and then we'll move from there. All right, so this is the equation in matrix form. This is the system of equations in matrix form. I put the maximizing equation at the bottom, just like normal. Then you look at the bottom row, and the most negative one wins. That picks our pivot column, negative 16. And then we do our division again to see which number in that column we pivot off of. So 16 divided by 3, that is 5 1/3. 8 divided by 2 is 4, so that's winning so far. And 4 divided by 2 is 2. Oh, that's the best. So we're going to pivot off this number. And I'm going to move this to a new screen so we can show our pivots. Okay, so pivoting off of the first column, this number 2, and I need to turn that into a 1. So simply row 3 divided by 2. That replaces row 3. And reminder, this y sub 1 variable replaces this slack variable on the very next step. So the very next step, I'm dividing everything in row 3 by 2. And row 1, row 2, and row 4 stay the same. So let me write that down real quick. So notice row 1, 2, and 3 are row 1, 2, and 4 are the same. I replaced x sub 3 with y sub 1. And I'm getting ready to divide each number in row 3 by 2. So here 2 divided by 2 is 1. 1 divided by 2 is 1/2. 1 divided by 2 is 1/2. 0 divided by 2 is 0. 0 divided by 2 is 0. 1 divided by 2 is 1/2. And 0 divided by 2 is 0. And then the 4 divided by 2 is 2. Next, I'm going to use row 3 to change all the numbers. Let me go ahead and, again, this is still my pivot number. All the other numbers in that column need to be changed to zeros using row 3. So I have to change the 3 to a 0 with a -3. So -3 row 3 plus row 1 replaces row 1. Then I have to change the 2 to a 0 with row 3. So -2 row 3 plus row 2 replaces row 2. And I have to replace row 4, this -16, with row by using row 3. So 16 times row 3 plus row 4 replaces row 4. All right, so I want to write that down real quick. So it's going to be -3 times 1 plus this 3 is 0. -3 times 1/2 is -3/2 plus 4. 4 is 8/2. -3/2 plus 8/2 is 5/2. And then -3 times 1/2 again is -3/2 plus 5. 5 is 10/2. -3/2 and 10/2 is 7/2. -3 times 0 is 0 plus this 1 is still 1. -3 times 0 is 0 plus 0 is 0. -3 times 1/2 is -3/2 plus 0 is -3/2. And -3 times 0 is 0 plus this 0 is still 0. Finally, -3 times 2 is -6 plus 16 is 10. All right, second row. Just a second here. I'll erase all these dashes so we can see. Here we go, second row. So second row is -2 times row 3 plus row 2. So -2 times 1 is -2 plus this 2 gives me the other 0 I was looking for. -2 times 1/2 is -1 plus 3 is 2. -2 times 1/2 is -1 plus 3 again is 2. -2 times 0 is 0 plus 0 is 0. -2 times 0 is 0 plus 1 is 1. -2 times 1/2 is -1 plus 0 is -1. -2 times 0 is 0 plus 0 is 0. -2 times 4 is -4 plus 8 is +4. All right, let me erase these arrows. All right, we're going to do row 4. Row 4 is row 3 is multiplied by 16 and added to row 4. So 16 times 1 is 16, plus -16 is the final 0. Half of 16 is 8, plus -14 is -6. Half of 16 is 8, plus -12 is -4. 0 times 16 is 0 plus 0 is 0. 0 times 16 is 0 plus 0 is 0. So a couple zeros here. Half of 16 is 8 plus 0 is still 8. Half of 0 is 0 plus, or 0 times 16 is 0 plus 1 is 1. And 2 times 16 is 32 plus 0 is 32. All right. We look at the last column. The most negative number wins. That happens to be -6 this time. That's my pivot column. And my pivot number is found by division. So this time it's 10 divided by 5/2, which is 10 times 2/5. 5 goes into 10 2 times, and 2 times 2 is 4. 4 divided by 2 is 2. And 2 divided by 1/2 is 2 times 2, which is 4. Notice if 4 happened to be the smallest, you just pick one. If there's a tie, you pick one. But in this case, 2 is the smallest. So I am now pivoting off. So I'm now pivoting off this number 2. And notice I have to turn that 2 into a 1. So I'm going to divide all of row 2 by 2. And this y sub 2 variable will replace this x sub 2 variable on the next step. So let me set that matrix up. So I'm taking everything in row 2 and dividing it by 2, and that is my new row 2. So 0 divided by 2 is 0. 2 divided by 2 is 1. That's the one I'm looking for. 2 divided by 2 is 1. And then I'm going to have a 0, 1/2, -1/2, and a 0 and a 2. So now I have to use that new row 2 to change all the other numbers in that column, to zeros. So it's going to be -5/2 row 2 plus row 1 replaces row 1. It's going to be a -1/2 row 2 plus row 3 replaces row 3. It's going to be a +6 row 2 plus row 4 replaces row 4. So let me get that matrix set up. All right, so I'm going to do this really fast. -5/2 times 0 is 0 plus 0 is 0. -5/2 times 1 plus the 5/2 gives me my 0. -5/2 times 1 is -5/2 plus the 7/2 is 2/2 or 1. 0 plus 1 is 1. -5/2 times 1/4 is -5/4 plus 0 is -5/4. -5/2 times -1/2 is +5/4 plus -3/4 plus -3/2 is the same as -6/4. 5/4 and -6/4 is -1/4. 0 plus 0 is 0. The 2's cancel. -5 plus 10 is +5. Row 3 is -1/2 times 0. 0 plus 1 is 1. -1/2 times 1 plus +1/2 is 0. I get a 0 here. I get a 0 here. -1/2 times 1/2 is -1/4 plus 0 is -1/4. -1/2 times -1/2 is 1/4 plus 1/2 plus 2/4 is 3/4. 0 plus 0 is 0. And -1/2 times 2 is -1 plus 2 is +1. Final row, -1/2 6. 6 times 0 is 0 plus 0 is 0. 6 times 1 is 6 plus -6 is 0. 6 times 1 is 6 plus -4 is 2. 6 times 0 is 0 plus 0 is 0. Half of 6 is 3 plus 0 is 3. -1/2 of 6 is -3 plus 8 is 5. 0 plus 1 is 1. 2 times 6 is 12 plus 32 is 44. All right, let me rewrite this on another page. So No more negatives in the bottom, so we're done. But remember, the dual method, you read from top to bottom. X sub 1, X sub 2, and X sub 3. X sub 1 is 0, X sub 2 is 3, X sub 3 is 5, and the minimizing is 44. Verify it with the original minimizing equation. You'll see that's right. Good job.